Here we have a particle moving along the x-axis, and that means if the particle is moving to the right, that means your velocity is positive. If your particle is moving to the left, that means your velocity is negative. So in part A, and they said, when is the particle moving to the left? I thought that was like the toughest part of this one. I think you'll like the other parts better. But when is the particle moving to the left, that's when we need to calculate when is the velocity negative, when is the velocity less than zero. If you just write that down, they give you like a point or two just for that, right? So you don't want to leave anything blank. You can get something on there, do as best you can. And then the velocity is that cosine function. So what I first did is just, where is it equal to zero, right? Now just review some pre-cal stuff. Remember, just ignore your weird angle. Where is your cosine equals zero? That's on your unit circle, your quadrant angles. That's on your unit circle where your x value is equal to zero. So your x value is equal to zero at those two angles. And so you got to take whatever that weird angle is, set it equal to the pi over 2 and set it equal to that 3 pi over 2, and then multiply everything by the 6 over pi by the reciprocal to solve that for the t. So multiply by the 6 over pi, the pi's are going to cancel. 6 over 2 is 3, and then that's going to be 18 over 2, which is 9. That's where your cosine, your velocity is equal to 0. And then what I'm trying to figure out is where is the velocity positive or negative. So I took those two numbers, put them on a little number line. And then you're not really doing anything major here. You just know, like, if you were to use 1 and plug it in right there for t, you get the cosine of pi over 6. That's in quadrant 1. We know from your all students take calculus that cosine is positive in quadrant 1. If you take like 4 and plug it in, that means that you're going to get the cosine of 2 pi over 3, which is in quadrant 2. We know cosine is negative in quadrant 2. And if you plug in like a 10, that's the cosine of like 10 pi over 6, which is 5 pi over 3, which is in quadrant 4. And if that's in quadrant 4, we know from the all students take calculus that your cosine is positive in quadrant 4. And so you're looking for is a less than 0, and that's where we're getting in between the 3 and the 9 right there. Now letter B, it says write an integral expression that gives a total distance traveled. You just straight have to have these memorized, right? On your blue packet, the second page, there's your average value formula, there's your average rate of change. And I don't know why I mentioned that. I'm looking for, boom, down here, displacement, total distance traveled. If they say displacement, you just integrate velocity, gives you your net result. If they say if they say the total distance traveled, they want to count everything, the positive stuff and the negative stuff, the total distance that you're running there, that's going to be your integral of the absolute value of velocity. You didn't even have to do anything on this problem other than just know the blue packet like I gave you, right? Know those formulas, because in total distance travel, boom, I'm going to integrate that velocity, the absolute value of that velocity, in between 0 and 6. This was on the no calculator part. So, I mean, you didn't have to integrate that anyway, so don't worry about it. It just says write it, but do not evaluate. You just got to make sure you know that formula. Letter C, this is at least our third time seeing this. It says find the acceleration. It goes position, velocity, acceleration. So to go from velocity to acceleration, we're going to take the derivative of the velocity. So the derivative of cosine is a negative sign. Remember, the C derivatives are the negative answers. And so you're going to get a negative sign of that angle, leave that angle alone, times by the derivative of that angle. And then here's what we got to do. We got to first plug in the 4 for that acceleration. So that gives us a sine of 2 pi over 3. And then that's going to give us, that's radical 3 over 2. And then that's in quadrant 2, so that's a positive radical 3 over 2. And then you just multiply those together. That's the acceleration at 4. So the first part of that said find the acceleration, where you could just stop right here. So the first part of that answer was just this guy, find your acceleration, and then that's it, okay? The second part of that said, is the speed of the particle increasing, decreasing, or neither at t equals 4. So you didn't really need to go too far and get those exact answers. You just had to determine whether these two items were positive or negative. Because remember, from our blue packet, from the last couple of tests we had, I think we had on the 2003 test and also the 2005 or 7 test, one of those, or even the 4 test, one of those. We got that down here for you. Speed is increasing if velocity and acceleration have the same sign. Speed is decreasing if velocity and acceleration have opposite signs. So all I'm trying to do is figure out whether the acceleration and velocity are positive and negative, right? And so when I plugged in the 4, I got, a negative answer there. When I plugged in the 4 to the velocity function, that's this guy right here. That was the negative 1/2 right there. So you didn't even have to get those exact answers, right? If you know this is in quadrant 2, you know your sign is in quadrant 2 from your all students take calculus. So a positive number times a negative number gives you a negative number. And you know this is in quadrant 2, you know cosine is negative in quadrant 2. You could just say, hey, this is a negative answer right here. This is a negative answer right here. Or you could write down this is less than 0, this is less than 0. And then you got to justify speed is increasing at t equals 4 since the velocity and acceleration are both negative. Or you could say speed is increasing at t equals 4 since velocity and acceleration have the same sign. You know, they're both negative right there. All right, now letter D. This is something I would also just like you to study because this could separate us from the rest of the nation here. Whenever they say find the position, you have to always take into account the initial position. If you just tell me I drove 50 miles south, I have no idea what your position is unless you tell me where you started, right? So if I got to do a position, you got to always take into account the initial position. That's when I read these problems. Sometimes I don't know how I'm going to use these, but I just kind of jot down, like underline some important information because I'm probably going to have to use that at some point in the problem, right? So it tells us at t equals 0, we're at -2. So that's where I started this thing. So this is like x sub 0. That means this is where I'm at 0. And then I'm supposed to figure out where I'm at 4. So since I was given 0, I would start it at 0 and then pick it up where I left off at 0 and then go to 4. If they told me at t equals 1, I was at -2, then I had an x of 1 right there. That's like where you're at after 1 second. Then you would integrate from 1 to 4. You would pick it up where you left off always, right? So you always start with your initial position. So if you just integrate, if you forgot the initial position, you would get some credit for there. If you know to integrate velocity to get you position, if you just integrate between 0 and 4, that velocity function, you'll get some credit for that, but you're not going to get full credit unless you remember that initial position right there. So that's multiple choice free response. That's just a pretty important concept we're going to work with there, right? So thing is, practices, make sure you're doing this without the calculator, but I like to set it up at the beginning. Then when you integrate the cosine, you're going to get a sine. Your u is equal to that weird angle. Your du is a pi over 6, so you balance that with the 6 over pi. Plug in the 4, plug in the 0. Sine of 2 power 3 is a bracket 3 over 2. Sine of 0 is 0. And then you just merge those together. So that's like where you went in those 4 seconds. And again, this is where you started at 0 seconds. So there's your starting point, and then where you went, there's your final position after 4 seconds right there. Pretzels.